So I'm going to talk a little bit about setting goals and how we talk about energy goals, and really how we frame questions relative to architecture. So some of the things that we find in building simulation today, one of the big problems is that our interaction with engineers tends to be linear. We design something, toss it over the wall, and they crunch some numbers and throw it back to us, and if we're lucky, we can incorporate changes. Most often it's too late. And the question is normally one of efficiency, right? How many BTUs per square foot per year, or things like that. But design teams tend to be very passive about the passive approach, right? So can we start to think about how our buildings drive less? Can we open a window instead of conditioning? One of the things that we find in architecture is we use our HVAC systems really to guarantee comfort. So what we're really selling is comfort, not energy. So what if you could guarantee the same comfort but without, HVAC systems? So starting to think more about passive approaches. And then simulations tend to have tunnel vision. And by that, I mean, you look at single points in time very often, especially when you're doing daylight analysis or solar insolation, June 21st at noon, December 21st, summer solstice, equinoxes. But in reality, sometimes the real issue is somewhere in the middle. So can we start thinking about programs that address the entire spectrum? This one's actually really important. So there's a time lag between the design of something and the analysis and the feedback that you get from that. And really good analysis, I think, is kind of shortening that gap. So can we figure out ways in which we can shorten that gap? So as you're asking the question, you're getting feedback. Because really, the crux of this is, it's not about the answers, it's actually being able to ask the right questions. And then there's comparative modeling versus incremental modeling. And by that I mean, a comparative modeling is if you take building A, building B, and building C, and you say A is better than B, B is better than C. But why is A better than B? And very often that's where the black box programs that we use fall short, because it actually doesn't inform your intuition to tell you, well, what are the incremental steps that you take to get from A to B? What makes B better than A? So that's really important. You've all probably seen or heard this. All simulation models are wrong. So why do we model things then? Because some of them are useful. And this was a mathematician called George Box who came up with this theory. It's like, if we can find the useful models and not worry so much about whether they're exactly right or wrong, then we've achieved something. So a while back, I did a survey of project managers in our office, and we asked them about, this was a firm I used to work for, about where, how they use energy models and how useful they were. And, that's schematics, design, development, and CDs. And what we found was that the number of models that were both timely and understandable was staggeringly low. That's a 30%. That's below, Congress's approval rating, I think, I'm not sure. So we're not doing a very good job. What's actually even more of a concern is we're doing a really bad job in schematic design when the decisions are really crucial. And then we also asked them some subjective questions in terms of, do you find them useful? Do you find them very useful? There's actually quite a large percentage who said they were utterly useless. And this is, I wasn't questioning, design modelers. I was questioning project managers, the guys who take decisions on the, boots on the ground. And so that's really a concern for me. So if you look at the design process diagram, you've seen some version of this diagram, with the curves that go up and down and stuff like that. But the gist of this is, if you start your optimization at schematic design, you have that much room for improvement. the further you delay that, the less room for improvement you have. And we've all seen this proven time and time again in projects. The minute you start thinking about things over here, you've made the big decisions on your project. It's too late to do anything. So if you think about it, at some point there's an analysis team as well looking at answering questions related to the project. And as you go through the project, that information gap increases. And so what happens is, if you do a model input here, by the time they analyze it and get it back to you, you're over here. You might have gone 4 steps in the process. So what we really, and that time lag is based on an information gap, really. So the more information you give them to crunch, the more stuff they have to crunch. Basic, right? So what we're really looking at is a process that looks like that, where you start early and get iterative with your modeling. And it doesn't matter, that you're not asking the big questions in terms of, what's my total BTU? We shouldn't be asking kBTUs per square foot questions over here. We should be asking more pertinent questions about our projects at that stage. And really what I'm focusing on this presentation is that stage of the design. What are we modeling then? How can we be more efficient? And really, and I can't stress this enough, it's not about finding the right answers then, it's about asking the right questions. And that is really important. So, and the minute you come to terms with that, you're actually more comfortable about, hey, it's okay if it's slightly wrong. If it's taking me in the right direction, it's fine, right? So, the design process is cyclical. You start with a hypothesis, you break it down, and you analyze the bits, right? So you go from hypothesis to analysis, and then you put it back together, hopefully in an artful way. And that's your synthesis. But then you go through that cycle again, you find a new thing to study, right? So it's a process that builds upon itself. And then we use tools for this, right? And the secret to this is really important, is there's more than one. And that's key. What we tend to do in our processes is kind of focus on, the one tool, whether it's Grasshopper or Sapphira or Ecotect or whatever. It's like, I'm going to use that for everything that I can do. And in my mind, that's the wrong approach. So everyone knows what a Swiss Army knife is, right? And we had this conversation at the retreat. So the question really is, what would you use this for, right? If you had access to those, has anyone tried opening a can with that thing? It's a nightmare, right? And so taking this approach to modeling, I think is flawed in itself. What we really need to be looking at is, what are we trying to do? And can I pick the best tool for that? So develop your toolbox. And then the other question is, there's a BIM company who shall remain nameless whose approach is this, right? Let's just pack everything into one platform. But is it really appropriate? At that point, it becomes unwieldy, right? So the question is, can we find different tools that actually do things more nimbly? So is that really the best solution? So the second question, what would you use to paint your ceiling? The one on the right, right? Pick the right tool for the right job. But also remember that one size doesn't fit all. So understand what you're trying to do with that tool. So you wouldn't want to, you get it. So that's really important when you select your tools, when you're talking about analysis right up front, is understanding what you're trying to do, understanding when you're trying to do it, and what you hope to achieve out of it. So sometimes the direct approach is really the most important. Don't try to get fancy when, use Excel when you can. Excel is better than Ecotect because it's quicker. So use the simplest approach. And no tool is perfect. Every tool has its pros and cons. And it's really important to understand what the pros and cons of those tools are. So familiarize yourself with it. And this, the thing is, as architects, we tend to want the magic bullet, right? It's like I just want to press that button and have it tell me what the answer is. But it involves getting your hands dirty, understanding building science, really important. I can't stress that enough. Before you delve into the realm of these things, understand what it is that these tools do, understand what the inputs are that you're putting in, and really importantly, understand what the outputs you're looking at are. So just because it's telling you, giving you blues and reds and greens, that's not analysis. That's modeling. Analysis is what you do with the data afterwards. So use your toolbox, get familiar with your tools, and the most important tool is really the ability to question, the ability to ask creative questions. And this is why I think design is really an analysis process, right? And so analysis is a design process too. So just as an example, we look at an analytical timeline. And so this is intentionally blurred out because I didn't want to get into the weeds of talking about different programs. But you can look at it this way. So if you look at a timeline for a project, you have different things that you study at different stages. So early on, you might study massing, orientation, climate, benchmarking, what's the realm that we're looking at. Slightly later, you might start to study your skin, daylighting, basic HVAC systems. And then as you go through, you get more complicated. So really, at this stage, you shouldn't be worried about whether you have a reverse cycle chiller or not, or whether you can sort those out later. What you should be worried about is, what's the climate I'm in? What are the resources available to me? What's the benchmark? What's my building type? What should I be expecting? And then these are different criteria that we look at, from ease of input to, standard HVAC systems. Does it have a wizard? To simulation speed, accuracy. And each of those criteria are more valuable at different times in the design process, right? So right up front, you don't care about the accuracy of results. But over here, you don't care about wizard inputs, right? You're doing compliance modeling, lead modeling, or whatever. You don't care about a wizard at that point. And then over here, you have different programs. And this is just my rating for them, but you might have a different rating depending on your ease with the programs. And so you score them for each of these criteria. So now I can go here and say, okay, if I'm at this stage, this is important, which ones score high in that realm, and I can pick the tool for the right task. And this is just one way of looking at it. And so maybe there's different tools that fit in at different points in that timeline. From daylight analysis to glare analysis to simple, dashboard type tools, benchmarking, orientation, solar, all of that stuff. And then, so I'm a real big fan of dashboard type tools that give you real-time feedback. How are we doing on time? Okay, so if we have time at the end, I'll get into a couple of these dashboard tools. One of them looks at solar shading and things like that. The other one actually looks at setting energy benchmarks relative to finding opportunities for net zero energy. But the important thing is we use these upfront really early to kind of establish design strategies. This was a project, it was a patient bed tower that we did in Dallas. And I used the dashboard tool, which is a simple Excel tool that we developed, to understand the impact of shades on a southwest facade. Now, a patient bed tower at the time, 6 air changes per hour is what's required by code. And what we wanted to do was make sure that we didn't exceed that. So if you exceed that, you got to buy a bigger air handler, you got to buy bigger ducts. So it's an increased first cost. So we're in a meeting with the client, and he turns around and says, why do I need to pay for those shades? So I open up the dashboard. While we're having the conversation, within 2 minutes, I'm able to run these scenarios over here. So this thing actually looks at air changes per hour versus equipment loads. And you can pick your orientation. The red dot over here is where your room is at relative to, so if it's below the line, it means it actually needs additional cooling. If it's above the line, it means it's actually reheating. And so we were able to turn the shade on and off right there and figure if you went without the shades, you'd move up to 9 air changes per hour in those patient towers, in those patient rooms. So that took it off the table at that point. Then I was able to go into eQuest later on and actually model those airflow rates to figure out what the system was actually moving through those. So this is the eQuest model over there. And got validation that it was about 9 air changes. Now, if I was to actually start off with the eQuest model, it would have taken me about 2 weeks to set that up, run it, come back with credible numbers. At that point, the shades would have been out of the building. And then we'd have been fighting to get them back into the building. So having this dashboard tool up front helped us keep it in the process. It helped the shade stay in the project. So sometimes speed is really important. So we use different metrics through the process. You know, you guys are all familiar with these, hopefully. You know, EUIs, WUIs, or triple UIs as we call them, and carbon emissions. The other ones that, you know, we're starting to see more of now are things like daylight autonomy. You know, so that's looking at climate-based daylight metrics. So is everyone familiar with daylight autonomy? Show of hands, okay. So it's looking at, you know, how often in this climate, so it actually uses a weather file, can you turn off your lights based on actual climate data? You know, with that, we also do glare analysis, so understanding predicted glare, and that's one of the lessons learned from a project that I'll show you in a bit. Things like comfort, predicted percentage dissatisfied. As we get into more passive analysis, we're seeing more of that. And with clients, really, you've got to put them at ease with, you know, with comfort calculations. So we've recently started to look at programs like IES that help analyze passive systems better than eQuest. The other thing that some of our clients are starting to look at is things like absenteeism and productivity, because really, those two things affect their bottom line far more than, you know, energy use or even first cost does. That one's really important. And then, you know, there's other metrics that are different for each project. So there might be a project-specific metric that, you know, you come up with. And that's really important, is to come up with success measures for your project specifically. And then, so the idea is, you know, you constantly monitor this. So you set your goals at the charrette or at the kickoff or even before that, through benchmarking, through early modeling. And then you monitor your targets through your design process. So really, analysis is a continued process. And I work, you know, very closely with our designers all the time. So it's not just, you know, so I actually go to client interviews where we talk about this, and then we follow up through the process. And I find that talking about it at the interview actually keeps it in the client's mind. So it's really important. And then the other thing is to understand that it's all a cyclical process. So you start with the benchmark, and then you design, analyze, and hopefully redesign a few times. And then eventually you construct it, and this is where typically we walk away, right? That's the end of the process, we've done our job. But now we're seeing the paradigm shift. So we're going back and operating the buildings. We've actually, we're working on our third design, build, operate, and maintain contract, where we're actually responsible for the final EUI. It's an EUI guarantee. And it's scary, but it's exciting too. I think that's a direction that we're going to see the profession go to more. And so that involves measuring and setting up your building to be measured. And then hopefully tweaking your operations. What's important is then you go back and you reassess your benchmarks, and that's really key, is to understand that the benchmark isn't a static number either.